Hello students. In previous lecture, we had studied about what are microprocessors and evolution of microprocessors. Microprocessors does the processing of the computers. The definition which we had learned was the microprocessor is an IC that contains much of the processing capabilities of a computer. It is small but extremely complex LSI device that is programmable. This we had learned. Microprocessor is nothing but a CPU of a computer, you can say. It does the processing of the computer. All the arithmetic and logical operations are done by the processors like addition, subtraction, multiplication, logical and, or, XOR. All these operations are done by microprocessors. We had learned evolution of microprocessors. Here we have to keep in mind the timeline of the microprocessors. Like in first generation, we had talked about the year 1971 and 1972, and second generation 1974 and 1976. Either you can learn from here or you can refer this table for the evolution of microprocessors. In this video, we will start with microcomputer organization. Before starting with this topic, I want to discuss about the types of computers, categories of computers. First is microcomputer, second is mini computer, third is mainframe computer, and fourth is supercomputer. As we are moving upwards from microcomputer to supercomputer, the cost of the computer increases, the processing speed of the computer increases, and the storage capacity of the computer also increases. So microcomputer, the example of a microcomputer is laptop, your PCs are the examples of microcomputers. Mini computers are those computers in which multiple users can be connected to the mini computers. Microcomputers as single user computer, but mini computers are multiple user computers. Third one is mainframe and fourth one is supercomputers. So they, mainframe and supercomputer, both do different tasks. Mainframes always deals with data and supercomputers deals with the speed in which it can complete a given task. Mainframe deals with how maximum amount of data to be processed in a particular given time frame, but supercomputers focus on the speed, how fast it can complete a given task. So now you know the classification of computers: microcomputers, mini computers, mainframe computers, and then supercomputers. So the processors first were evolving. They were evolving in the direction of microcomputers, and then after that, in third generation, the evolution was towards mini computers. So in today's topic, we are going to do microcomputer organization. Computer system always contains 5 main blocks. Of course, it has input and output device. Input device and output device. Third one is CPU, which has arithmetic unit and control unit. And fifth one is memory unit. If you go by the list given in your textbook, first is input device, second and third is central processing unit with arithmetic unit and control unit. Fourth one is memory unit, and fifth one is output device. Now, this is the block diagram of a computer. It has an input device, it has output device, it has CPU in which it has arithmetic and control unit, and it has memory unit. The memory unit has two types of memory. One is program memory, second one is data memory. Program memory is used to store the instructions, data memory is used to store data. In processors, the designer of the processor, the manufacturer of the processor, a particular processor, has designed instructions, particular instructions for that processor. The manufacturer designs the instructions for the processor. Those instructions are stored in the memory of the processor. These instructions come along with the processor in a data sheet. Like for 8085, which we are going to learn about Intel 8085A processor, it has 74 instructions. These instructions were designed by the manufacturer, and these instructions come along with the processor in a data sheet. Okay, these instructions can be addition of two numbers, subtraction of two numbers, decrementing the given number or incrementing the given numbers, perform the add operation, perform the logical OR operation, perform logical XOR operation, jump from one memory location to another memory location. These instructions are already fed into the processors by the manufacturers, and the processors come along with data sheet in which all the instructions are mentioned in that data sheet with its explanation what this instruction does. So program memory stores the program, data memory stores the data. For example, I want to perform add instruction. Add instruction requires at least two numbers to do the addition. So those two numbers are nothing but data. Okay. Input device. A list of instructions with data is stored in a memory, either for short time or permanently. Data is either stored temporarily or permanently. The instructions which are stored in a memory, that memory is known as program memory, and data which is stored in another part of memory called as data memory. After feeding set of instructions into the memory, control is used to read the first instruction from the program memory. This control unit is used to read the instruction from the program memory, and according to that instruction, control unit performs the work. The CPU performs the work with the help of control unit and arithmetic circuit. That operation can be addition of two numbers or jumping to other memory. After performing desired operation, result is transferred to the output device. So this was the microcomputer organization. So basically what was there in this? Instructions are stored into the program unit and data are stored in data memory. Control unit is used to read the instruction from program memory, and according to the instruction which has been read by the control unit, arithmetic unit and control unit perform the given work like adding of numbers or jumping to another memory. After performing desired operation, result is transferred to the output device. This was the basic organization of microcomputer. Now we will learn about generic microprocessor, a general purpose microprocessor. What a general purpose microprocessor has, that we are going to learn in this topic. Generic microprocessor gives an idea of simple architecture of a general microprocessor. It is a general model showing essential blocks in a microprocessor. We are going to learn the different blocks present in a general microprocessor. This figure shows a generic microprocessor with internal blocks connected in a logical structure to perform arithmetic and logical operations with data bus and address bus. Data bus and address bus are Data bus carries the data. Address bus carries the address of a particular memory location, address of a particular device. To learn 8085, this model of generic microprocessor becomes helpful. This generic microprocessor has all the essential blocks a processor has. So if we will understand the generic microprocessor, then it will be easy for us to understand 8085 microprocessor. A generic microprocessor includes following blocks and required set of bus. So these are the blocks. First is arithmetic logic unit, which is ALU. Second is registers. Third is instruction decoder. Fourth is timing and control section. Fifth is interrupt control. Sixth is three types of buses. We will learn in detail each of these points one by one. Arithmetic logic unit. It is a digital circuit. It is 8-bit unit. That means at a time it deals with 8-bit data, where arithmetic and logical operations are carried out. In arithmetic logic unit, arithmetic and logical operations are carried out. Arithmetic means addition, subtraction, multiplication. Logical operations like logical AND, OR, XOR. After performing the operation, it sets the flags according to the nature of the result. We will be learning about flag register. What happens is, when your answer is 0, after performing subtract operation, for example, after performing subtract operation, if my answer is 0, then Z flag is set to 1, which determines the processor that the answer is 0. So Z flag, depending on the operation, processor sets the flag. If my answer is 0, then Z flag is set to 1. That means the processor will come to know that the result of the operation is 0. So arithmetic logic unit is an 8-bit unit where arithmetic and logical operations are carried out. After performing the operation, it sets the flags according to the nature of resulting answer. Now I hope you understood. Second is registers. Registers are used to store data. These registers can be of 8 bits or can be of 16 bits. Some registers can store 8-bit data. Some registers can store 16-bit data. One of the register is accumulator. This is used to store the result. For example, if I am performing addition operation, for example 1 plus 2, I will get 3. 3 is stored in accumulator. This is the main register is used to store result of arithmetic or logical operation. So the result is stored in accumulator. There are some general purpose registers. Register B 8-bit, register C 8-bit, register D 8-bit, register E 8-bit, register H 8-bit, register L 8-bit. Register B, they are general purpose register. We can use it to store any type of data. But the length of the data is 8-bit. Status register. Status register is nothing but a flag register. It is a set of flip-flops. Either the register can be set to 0 or set to 1. For example, I had given you an example of Z flag. When my answer is 0, Z flag is set to 1. When my answer is not 0, Z flag is set to 0. So it is the status register is a set of flip-flops called as flags. Flip-flops means flip-flop is a circuit. A flip-flop is a circuit that has two stable states and can be used to store state information, either 0 or 1. Microprocessor, this general, we are talking about general microprocessor, not 8085. A general microprocessor has two flags, one is carry flag and one is zero flag. Carry flag is when I add two numbers, for example, 9 plus 10, or or sorry, for example, you are adding 90 plus 10, what you will get? 100. That is one carry. So carry flag will be set to 1 if there will be carry. If there is no carry, carry flag will be set to 0. Now, program counter is a register which is of 16-bit. It is a 16-bit register. It is used to store 16-bit data. The purpose of program counter is to store the memory location of next instruction to be executed. To perform addition, I will be having set of instructions. I'll have set of instruction. There are, for example, 5 instructions and I'm on first instruction right now. The purpose of the program counter is to point to the next instruction, which is the second instruction. The purpose of the program counter is to point to the memory of the next instruction to be executed. So it can store up to 16-bit. Then stack pointer. Stack pointer is also 16-bit, which is used to store address of a memory. Again, it is used to store the address of a memory. But the purpose of stack pointer is, for example, there are 5 instructions in series to be executed to perform some particular task, to perform some particular operation. I am on second instruction. First instruction has been executed. My next instruction is in execution. But the next instruction is to jump to some another memory location. Next instruction is to jump to some another memory location and execute those set of instructions which are in series on that particular memory location. Once executed, it should be back to the second instruction again, or third instruction, not on second, third instruction of the current set of instructions. So what is happening? The program counter should point to the next instruction, to the memory of the next instruction. But what happened? I had to jump to some another memory location where some set of instruction is stored. But once my program is trying to come back from where it had jumped, how will the processor come to know where it had left? So the stack pointer will store the memory where the processor had left its series of instruction and jumped to some other memory where other set of instructions were stored. Ninth is instruction register. Instruction register, it is of 8-bit the first byte of instruction is loaded in this register. Okay, instruction is stored in this register. Then instruction decoder. As its name suggests, it takes instruction from instruction register, decodes it, and it sends the control signals to a particular block in the processor depending on the instruction which it has decoded. Fourth, timing and control section. As per signal given by instruction decoder, it generates appropriate signals to control respective device in order to execute the instruction. For example, my instruction was to display the output. Instruction decoder will take the instruction from the instruction register, it will decode it, and it will send the signal to what? Timing and control section. Once the signal is received by the timing and control signal, it generates the appropriate signal which will send the signals to the output device because the instruction was to display the output. Okay. Fifth one is interrupt control. We had learned interrupts in 11th. There was one chapter in which we had learned about interrupts. For example, I'm on a call. On my phone, I'm on a call, and some other friend in my friend list is calling. So we can see this is an interrupt. Likewise, in processors also, there is a concept known as interrupt. To control these interrupts, we have interrupt control. Interrupt is an essential process in microprocessor. It executes certain steps when interrupt occurs. When interrupt occurs, then interrupt control decides what to be done, what signals to be sent, where it should be sent, depending on the kind of interrupt the processor has received. Then, sixth one is three types of buses. Buses are used to send data, or carry address. There are three different types of buses. One is address bus. Address bus is 16-bit bus and it is unidirectional. Unidirectional, that means it can only read the address. No write is there. Only read, unidirectional. Data bus, it is 8-bit. You have to remember that. Address bus is 16-bit. Data bus is 8-bit. The difference between the address bus and data bus is bidirectional. We can read the data also and we can write the data also. Then control bus. Control bus is used to carry the signal to execute a particular operation. Like here what had happened, instruction decoder had taken instruction from the instruction register, it had decoded it, and it had sent the control signal to the time and control sections, and then timing and control sections had sent the control signals to the output device depending on the instruction. Like for example, the instruction was to display the output. Okay, so control bus carries the control signals. Next topic is block diagram of microcomputer. We have already discussed the microcomputer organization. This diagram is important from exam point of view. Block diagram of microcomputer. The block diagram has five blocks: input device, output device, control unit, arithmetic unit, memory unit. Memory unit is divided into two: program memory and data memory. This we have already learned before. But here we will learn the detailed architecture of a microcomputer. Now if you'll see the diagram, here we have an input device which is keyboard. Keyboard is used to give input. But there are possibilities that microprocessor is currently busy executing some particular instruction which was given before. And in between, keyboard has sent some input, some program along with data. But directly giving the input to the microprocessor, there is keyboard interface in between. It's a chip where this data and program and data is stored for the time being, because there are chances that microprocessor might be busy performing some instruction. This keyboard interface then will send interrupt signal to microprocessor that there is some interrupt. There is another reason why keyboard is connected to keyboard interface is that speed of the input device. The speed of the input device and the speed of the microprocessor may differ. One might be slow, one might be faster. So keyboard interface is needed. After storing the program or instruction and data in the keyboard interface, it tells the CPU through the special signal line, which is interrupt line. Can you see? This line is interrupt line. Okay, this line is interrupt line. This line is interrupt line. Keyboard will send interrupt signals to microprocessor. After microprocessor completes the current instruction which is in execution, it stops the normal execution and jumps to a special group of instruction in its monitor program. Monitor program is nothing but ROM. Can you see? This is ROM. Microprocessor, once it will complete its current instruction in execution, it will stop the normal execution and it will jump to the monitor program, which is nothing but ROM. Monitor program is also known as ROM because ROM is read-only memory. All the instructions are stored in ROM. So after jumping to the ROM, it gives response to the keyboard. Once it after reading instructions from the ROM, it will send instruction to keyboard to start sending the input to microprocessor for processing. This keyboard interface, if you will check, it is connected to data bus. आपको ये दिख रहा होगा, this is the data bus. This is the data bus. See, data bus. Data bus is used to carry data. It is bidirectional. Can you see these two arrows? This determines that it is bidirectional. Why there is only single arrow here? Because ROM is read-only memory. We can only read the data. We cannot write the data to the ROM. Here RAM is random access memory. We can write data to the RAM or we can read data from the RAM. That's why it is shown as bidirectional. Data bus is bidirectional display interface. Then this keyboard interface is also connected to power supply. Of course, every block in a microcomputer requires power supply. It is also, keyboard interface is also connected to address bus. Can you see this? Address bus. It is 16-bit. It is used to carry address of a particular location, and it is unidirectional. So can you see the arrows? Only it is shown in one direction, not like this. This is bidirectional. Data bus is bidirectional. Address bus is unidirectional. As an input device has its own interface, output device also has its own interface. Like display is the output device, display interface is required for the output device display. There is chip select lines. Chip select lines means chip select is the name of a control line in digital electronics used to select one of the ICs out of several connected to the same computer bus. Here, if you will see, there are multiple blocks in the microcomputer. Multiple blocks are connected to this line. But chip select is used to select one block out of many blocks available. So chip select selects the which block should be in use here. Then we have address decoder. Address decoder is a binary decoder that has two or more inputs for address bits and one or more outputs for device selection signals. It is nothing but it is used to decode the address. The address, it will decode the address. It will tell the processor that this location, at this location, the output devices, input devices. This microprocessor is also connected to a clock. All the ICs on a particular board, all the blocks are synchronized with the clock. All the blocks work according with this clock. A microprocessor has its own clock. This is basically is all about the bus, address bus, data bus and control bus, which we have discussed. Input device keyboard also we have discussed. MPU is also we have discussed. The function of microprocessor unit is to receive information, to process that information by means of arithmetic and logical operations, and to send the result or information, display the result or send the information. ROM is program memory, RAM is data memory, output device is display. 7-segment display means, see, 7 LEDs display, 7-segment LED display. Address decoder. It decodes the particular address and points out which device it is talking about, which is connected with the processor. Clock we have discussed, with which whole circuitry is synchronized. The speed of the system also depends on clock frequency. Power lines, power supply. So for today we will end here. In next video we will start with the 8085 microprocessor. If you have any doubt, you can write in the comments. Thank you.